In this example, let's take a look at some horizontal shifts. We're going to be working with the graph of y equals x squared, which is going to be our parent function. Remember that our parent function is going to be in the form y equals f of x, and the f of x could be any of the functions that we're working with. So something like x cubed, or the absolute value of x, or the square root of x, any of those could be our parent functions. Okay, let's take a look at comparing this one with the graph that we have in part B. We have the graph of y equals x minus 3, the quantity squared. So we're going to go ahead and graph these two together. And let's take a look at what happens, right? Our original graph, our parent function of x squared, is graphed in red. And if we take a look at the graph in blue, you're going to notice that the graph of x minus 3, the quantity squared, is a graph that has been shifted over to the right a total of 3 units. And let's go ahead and take a look at our next graph. This time, we're going to be working with our parent function, which is x squared, graphed in red. And we also have the graph of y equals x plus 2, the quantity squared, which is graphed in green. Right, we have these graphs over here on our right-hand side, and you'll notice that this time our original graph, our parent function, was moved to the left a total of 2 units. Right, so these are known as our horizontal shifts. We're going to be moving the graph left and right. And let's just go ahead and make some general notations here. We've got our original graph in the form of y equals f of x. We decided to use the x squared function here. Okay, and this time, if we're taking something where we're moving the graph right and left, let's talk about the notation we're going to be using. When we're talking about moving a graph to the right, we're going to be writing this in the form of y equals f of x minus h. And in this case, our h value is going to be something that's positive. Okay, this is going to be moving our graph to the right a total of h units. If it's in the form of y equals f of x plus h, okay, our h value here has to be something positive, then this is going to be moving our graph to the left h units. So let's go ahead and talk about what happens when we start to combine both horizontal and vertical shifts on our graph. So we're going to go ahead and keep working with that x squared function. This is going to be our parent function. Remember, it's in the form y equals f of x. F of x can be any of the functions that we're working with. And let's take a look at the equation here in part B. We've got y equals the quantity x plus 3. The whole quantity is going to be squared. So if we're reviewing this part, when you have the plus or minus some numerical value inside with your x term, this is going to be one of our horizontal shifts. Great, and if we take a look at the graph of these, we have them both sketched below. You'll notice that this graph is moving to the left a total of 3 units. Okay. And we can combine additional shifts on our graph. Let's go ahead and take a look at what happens when we take that same equation, and this time we're going to go ahead and subtract 5 all the way at the end of it. Okay, so this time the minus 5 appears all the way at the end. This is going to cause some type of vertical shift. And And because we have the -5 at the end, this is going to be taking our graph and moving it down a total of 5 units. And if you take a look at the graphs here on that right-hand side, the red graph is our x-squared graph. That was the original parent function that we started with. You'll notice that we went ahead and moved that graph to the left a total of 3 units, where it became the blue graph. And then we went ahead and took that one and moved it down 5 units, so our final graph here, after all these shifts are completed, is going to be the graph that you see in green.